Okay, so hi guys. So in this video, what we're gonna do, and so I don't think that I've gone over condensing and expanding logarithms. So in this video, I'm gonna do a few examples. So I'm gonna do three where basically I am expanding the logarithms. And I am gonna do, let's see, some other three where I am condensing logarithms. So before we even get started, what does it mean to condense and expand logarithms, right? So, for example, if I just look at x squared plus, or actually let's do x squared plus 2x plus 1, right? And I want to condense it into one factor, right? That just means x plus 1 quantity squared. That's how we condense it into one factor, right? Or into a binomial factor mostly. So that's kind of what we're gonna do with logarithms. Now, I do have a video where I go over the laws or the rules of logarithms, and so I do highly recommend, and I will post a video in the description, or a link in the description for that. But basically, I want to make sure that we do understand all the rules of logarithms, okay? Because we have to use those to understand exactly how these are done. And even when solving logarithmic equations, which I'm not going to get into in this video, but I just want to make sure that we understand the rules of logarithms, or the laws of logarithms, or they also call them properties, so that, like, I want us to understand those before we actually, or actually, if you it's very recommended that you have them right in front of you. And if not, you can go to my other video and I go over them one by one. So let's get started. We have number 1. We have log base 2 of x cubed. So log base 2 of the quantity x cubed y over z squared. And we want to expand this logarithm, right? Our goal is to expand it. So our goal is to expand, okay? Now, we know just from looking at this, and one of the things that you should notice is that the first property which should come to mind is the quotient property, okay? And that is log base b of x over y equals log base b of x minus log base b of y. That is the first thing that I'm going to do here. Now, here I have a base of 2, so I'm going to say, and it kind of helps, and if it helps I can color code, so I can say log, and I can say base b of x over, and I can say y, or let me use another color, y, and I can say this is equal to log base b of, and it's x minus log base b of y, right? So that's the first rule, and we're going to do that here. So here we're going to say log base 2 of, and it's going to be x cubed y, and then minus log base 2 of z squared. Now, that is, we use the quotient property for this, right? So here we specifically use the quotient property to do this, to basically do this part here. Okay, now the next part is you want to look at each of these terms and you want to try to expand them as much as possible, right? We know the second, so to do that, basically you want to go ahead and use the product property. And that is that we have the log base b, and we have of x, y equals log base b of x plus log base b of y, right? And that is a product property. That is what we're going to use right here. So, well, we're going to use it for this first one specifically. So that means that if we just look at log base 2 of x cubed y, okay, that's going to be log base 2 of x cubed plus log base 2 of y. And so that is what goes for, that is what goes here. Okay, this is what this is really. So we can rewrite it and we can say that this entire thing is really just the following. Log base 2 of x cubed plus log base 2 of y minus log base 2 of z. Or z squared, excuse me. So now we've expanded in terms of, you know, product property, and we also use quotient property. And now, you know, there is one more thing that we need to do though. We're almost there, but we have to do one more thing to this. And that is the third part, which we're going to use another property, and it's called the power property. So this one says that when I have the log with a base of b of the quantity x, and then it is to the n power, this is really just equal to n log base b of x. So that's what we're going to use here. Now notice that for the log base 2 of y, we don't really have to do that, because even if we move the 1 to the front, 1 times log base 2 of y is just log base 2 of y. So for this, for the middle term there, we don't really have to do anything with that, right? So we use the power property, and so basically the 3 is going to move to the front, so we're going to say that this part is equal to 3 log base 2 of x, and then we have plus log base 2 of y, and then we're going to move the 2 right here, we're going to move it to the front, so it's going to be minus 2 log base 2 of z. Okay, and so that is your final answer. Now let's see, give me 1 second. So yes, that is your final answer. So the second one, so this is how we do the first one. This is the answer for this one. That's how we expand. So you see how we expanded. We used the quotient property, the product property, and then we used the power property. Okay, so that is for the first part here. That is how we do this first problem. Now for the second problem, it says log base 3 of the square root of x, so log base 3 of, and we're gonna do square root x over y z squared, and we want to expand this so that it looks kind of, you know, we want to make it bigger, right? We want to make it expanded. Expand means to make it bigger, just like I said with the quadratic equation, or the quadratic function, right? So here we're going to say that this is really, so again, you look at your quotient property. So quotient property, log base b of x over y, and like I said, I really recommend that you have them right in front of you. I wrote them up here, but I really want everyone to make sure that you have them in front of you. So this one, what we're going to do is we're going to go ahead and, one of the things I do recommend that you do for this is, so there is one property that is called the square root property, and that is that, so that is this, hold on, so it is that the nth root of a raised to the p power will be equal to, that's going to be equal to that's going to be equal to a raised to the p divided by n power, right? And so that is how you write that. And so we notice that here the square root of x, so the square root of x is really just the second root of x raised to the first power. And if I color code that, we have 1 right there, and then we have 2 over here, right? Let me actually do it this way. We have 2 right here, and then we have x, and then we have the, sorry guys, hold on. Give me 1 second, 1 second. So this part is 2, and then this part is 1. So that's why this is really just equal to x raised to the 1 over 2 power, right? And that is something that we must remember about this. Now, looking at the problem, that means that we can write the logarithm as log base 3, and we can say the following. We can say that this is equal to log base 3 of x to the 1/2 power over yz squared. And now we want to go ahead and say that we want to use the quotient property, right? Remember, log base b of x over y equals log base b of x minus log base b of y, right? So this is going to be log base 3, and we're going to do the top portion. So we're going to do log base 3 of x to the 1/2. So that's this part. And we're going to subtract log base 3 of yz squared. Okay. Now, one of the things that I do recommend for this one is that you split up. So you want to go ahead and split this up. And it's tricky because the thing is, you have to be careful when you do that. So here's the thing. You can move, so you can say the following: log base 3 of x, and you can make this to the 1/2 power. And you can say minus, and then you can say log base 3 of yz squared. And also make sure that you move this to the front. So you're going to say 1/2 log base 3 of x. And then it's going to be minus log base 3 of yz squared. Now pay really close attention to what I'm about to do with this log base 3 of yz squared, because I feel like this one can be tricky, and I did I was tricked a little bit by this one at first, so because you have to be very careful. So the thing is, you're gonna keep log 1/2 log base 3 of x, right? But what you're gonna do is you're gonna split this into two logarithms. However, what you're gonna do is you're gonna put a minus and you're gonna put a bracket. Because the reason why I say that is because honestly, this is one logarithm in and of itself. This is like saying 1/2 log base 3 of x minus log base 3 of yz squared. Okay? So in reality, when I do the product property for this, I want to make sure that before I do that, I put my bracket here because I want to make sure that I don't confuse myself. Because then you're gonna put, if you don't put the bracket, you're going to mess your answer up, and you're gonna think that it's gonna be minus log base 3 of y plus log base 3 of z squared, which is, and you're not gonna distribute your negative. That's the thing. So you have to be careful. So the way that you're gonna do this is you're gonna put minus and you're gonna put log base 3 of y, and then you're gonna say plus log base 3 of z squared, and another bracket here, because that is your entire term. Now you can go ahead and distribute your negative. And you can write this as log base 3 of x all over 2 minus, and you're going to do log base 3 of y minus log base 3 of z squared. Now, we're almost done. So this one, we're almost done with this one. So basically, you're going to go ahead and say log base 3 of x all over 2, and then you're going to do minus log base 3 of y, and then remember log base b of x to the p is really p log base b of x. That's what it is. You move the p to the front, the power. You move the power to the front, so you're going to say minus, you're going to move this to the front, 2 log base 3 of z. And so this would be your answer. You can say 1/2 log base 3 of x minus log base 3 of y, and then minus 2 log base 3 of z. But in reality, I mean, it's fine if you don't say that. So basically, let's see, give me 1 second. So yes, I believe that's how you do it, because the thing is that you have to be careful, and you have to put, so the bottom part, you have to split it into two logarithms, but you have to make sure that you put brackets, and that's why this answer is like this. Okay. So let's move on to the next one. Log base 3. So let's number 3. Log base 3 of the quantity x minus 3 quantity squared over y squared z to the 6. Okay, now here's the thing. You have to go ahead and just go ahead and split this into two logarithms. So you're going to use quotient property. Remember, anytime you see a division, you always subtract. So you do log base 3 of x minus 3 squared minus log base 3 of y squared z to the 6, okay? So this is your first step. This is step 1, right? So then after that, you're going to go ahead and move the 2, you're going to move it to the front. So you're going to see this is really just because you use the power property, remember? So 2 log base 3 of x minus 3 minus, and you're going to put a bracket because remember we're doing a product of 2 things. Anytime you see more than 2 things here, so like if I see more than 2 letters here, or more than 1 letter, 1 variable, then that means I'm going to have to make this, and if I'm subtracting, that means I'm going to have to make this into a bracket. Because I want to make sure that I split it into 2 logarithms. And like I said, anytime you have a logarithm with 2 terms in the inside of the parentheses, you always split it into 2 logarithms. So this is going to be log base 3 of y squared plus log base 3 of z to the 6. And then bracket. Okay, so then this is going to be 2 log base 3 of x minus 3. And then you're going to do minus, and you can go ahead and distribute your negative. Log base 3 of y squared minus log base 3 of z to the 6. Now we're not done yet. Remember, you have to move the power to the front. So you're going to say, just like we did up here for log base 3 of x minus 3, we want to do that exact same thing for this term here, these 2 terms really. So we're going to say 2 log base 3 of x minus 3 minus, and it's going to be 2 log base 3 of y minus 6 log base 3 of z. Okay, now you can, if you want, factor a 2 out of this, and that's going to give you the following. So if you factor a 2, so if you divide everything by 2, this will give you 2 times the quantity log base 3 of x minus 3 minus log base 3 of y. And let me just kind of explain this. So you're going to say 2 log base 3 of x minus 3 over 2 minus 2 log base 3 of y all over 2 minus 6 log base 3 of z all over 2. So this cancels out. We have log base 3 of y, or log base 3 of x minus 3. And then this cancels out. This is minus log. So in reality, whenever we divide by a number, we're just going to go ahead and put a parentheses so that we can factor it. So remember how I said, if you do 2x minus 6 and you divide by 2, that's really just 2 times x minus 3. That's exactly what this is. So 2x minus 6 equals 2 times x minus 3. If you multiply by 2 on both sides again, right? That's what we're doing here. We're dividing it, but we're also making sure that we're multiplying it back in, but in terms of parentheses, right? That's how you factor. So we have 2 times log base 3 of x minus 3 minus log base 3 of y minus 3 log base 3 of z. And so let's see. I just want to make sure I did this correctly. Yes. So this is your final answer. Okay. Now, so let's move on to number 4. Now what we're going to do is we are going to condense logarithms. So before we were just doing expanding, we were making it bigger. Now we're going from this to whatever we started with in this place. So let's do that. So basically before, so just to recap, when we were expanding, we went from log base b of something to log base b of something, or really it's like log base b of something, something, something. And let me kind of just, so just to recap, I'm kind of just doing a little bit of a recap here. Expanding means to go from this to this. Right? And we used that, we did expanding with properties of logarithms, right? So now we're going to do condensing. What I mean by that, we're going to make the logarithm, it's going to be expanded, we want to make it smaller. So first we were going from small to large, and now we're going from large to small, okay? So expanding is a different, condensing is another thing. So condensing, so number 4, we do number 4, we go ahead and say, so this one is log base 2 of, and it's w plus 3. Let me go ahead and write it very quickly. So this one, we have log base, so basically, make sure we, it says log base 2 of w plus 3 plus log base 2 of 3x squared minus log base 2 of y squared plus log base 2 of 4z minus 1. So this one, we want to make sure that we condense it. This is, for this one, we have to condense it, right? So notice that all of them have a base of 2. Look at the number here. They all have a base of 2, right? So this makes it pretty easy. And the thing is that almost all of them are going to have a base of 2, or at least I would believe all of them do, or have, I'm sorry, not a base of 2, the same base, excuse me. So the thing is, you're going to make it so that this is a log of something, and you're gonna use the properties of logarithms to fill in what's gonna be inside the parentheses, right? Now, one of the things I would recommend is that if you have a plus, if you're adding logarithms, go ahead and write it so that you're first adding all of them. So log base 2 of w plus 3 plus log base 2 of 3x squared, and then plus log base 2 of 4z minus 1, okay? So, like that. So first we're going to add, and then we're going to subtract, and then we're going to do a minus log base 2 of y squared, right? The reason why I say that is because, again, when you're, the thing about, if you notice about these other ones, like one of the things that we should notice about these is that the thing is that first we had to add it and then subtract it, right? That's why I'm kind of making it so that it's like this. We're adding and then subtracting, and not the other way around. So that's kind of why I want to make sure this is rearranged so that it looks like we're adding first and then subtracting, so that way once we condense it, we don't have to do an extra step, right? And we're not getting confused with, do I divide, do I add, or do I multiply, right? So this one, we want to make sure always when you have separate logarithms of the same base, you always want to make sure you do the addition first and then subtraction, so that way when you condense it, it flows more smoothly, right? So we have log base 2 of w plus 3, and here's the thing. So you're gonna have the log base 2 of something, right? That something is gonna be depending on what you're multiplying and dividing. Now remember what I said, that log base b of a plus log base b, or log base b of x plus log base b of y is really just log base b of xy. So what does that mean if we're adding two logarithms of the same base? What does that mean for the inside portion here? What does that mean for for these three things? Well, it means that we're going to multiply them, right? So we're going to do w plus 3 times 4z minus 1 times 3x squared. Now, and then at the end we're subtracting. So what does that mean? If we have, if for example I have, it's like I said, if I, in the quotient property, if you have a log of something minus a log of another thing, right? And we already did all of these, we multiplied it. So what does that mean? That means that all of these are going to be divided. Think of this as, think of u as being, so here's another way I can write it. Log base b of u over v. Think of u, we already found what u is. U is equal to w plus 3 times 4z minus 1 times 3x squared, right? But now we have to just do it over v so that, you know, because we're subtracting, right? All of these are the terms that I highlighted up here. They're all the ones that are multiplied. But now we're subtracting something. So what does that mean? That means that the bottom part, this part here, is really going to be this part. So that means that for this problem, I'm going to put y squared at the bottom, because again, it is a difference of logarithms of two bases. But because we already did all the multiplication up here, because we were adding, and we did the product rule for basically for this part, for this entire part, now we go ahead and do the subtraction rule, which goes with the quotient rule, right? So that is why I put it over y squared, and that's why this, so log base 2 of w plus 3 times 4z minus 1 times 3x squared, that is why that one is, and then all over y squared, that is why this would be your final answer for this one, okay? Let's do a few more, and then that'll be it for this video. So number 5, log base 7 of 4x, so we have, let me go ahead and write it down. So here's the thing, and this is where I really want to kind of, you know, so the thing is that sometimes, and I do believe this, that, I mean, I'm not sure if they're going to give it to you like this, where it would be something like this. Here's the thing, is that when you're doing it this way, you always, it's like I said in the previous problems. I'm not sure if I said it, but so basically the thing about this one is that when I say y minus 3 squared, I mean only y minus 3 is being squared, not the entire logarithm. That is, I feel like that's one of the biggest confusions, you know, about logarithms. And the thing is that the power property says that you have to square what is on the inside of the logarithm and not the entire logarithm. You never square the entire logarithm, because that is not what the power property is. The power property is that you only square whatever you take the logarithm of, right? So basically my point is that log base b of x to the p power is not equal to something like this. Okay? These two are not the same. You have to really note the difference, because basically, yes, they're not the same thing. You have to make sure that you put the power inside, but you can say this like that, or like this, right? But sometimes the reason why they say it like this is so that you move this to the front, right? But you have to be careful sometimes when you have a squared term, but in reality, yes, this is being squared, but you're going to move it to the front, okay? Now, I mean, you don't have to do that for this one, because obviously this part here where the 2 is, you're not really going to do anything with that. And the reason why I say that is because so the reason why I say that is because, again, when you go from log base b of x to the n to n log base b of x, this is what we call expanding. So if you were to move this to the front, you would actually be condensing it, or I'm sorry, yes, condensing it, expanding it even more. So you would actually be expanding it even more if you were to like move the 2 to the front of the logarithm, right? So here you would have log base 7 of 4x, and the thing is, you have to say following. So you have to say log base 7 of 4, and then times x, because that kind of helps, minus log base 7 of y minus 3 squared, like this. And then plus, and what you're going to do, you're going to move the 3, this 3, you're going to move it up here. So you're going to say plus log, because again, we are condensing, we are making it smaller, right? So we're making it smaller, so when you're going from here to here, you're actually condensing it. So it's going to be log base 7 of z squared minus 5 cubed, right? So this is going to be log base 7 of, and it's going to be, so here's the thing, we're going to make it an entire term. It's going to be 4x, but notice, so basically, let me write it this way. Again, you're going to add first log base 7 of 4x. You're going to add your term first, so we have a plus log base 7 of z squared minus 5 cubed minus log base 7 of the quantity y minus 3 squared, like that. So the thing is that you have to go ahead and say, so again, you notice that all of them have a log base 7, so you're going to say log base 7, and then we're adding these two logarithms. So what does that mean? That means that we're going to multiply whatever is inside the logarithm. So we're going to multiply 4x with z squared to the 5th cubed, right? So 4x times z squared, or I'm sorry, z squared minus 5 cubed. And then we're subtracting, so what does that mean? That means we're going to divide by whatever, so we're going to actually divide by this entire term here. So we're going to have over, and it's going to be y minus 3 quantity squared. And so that one, so basically that is how you do that one, and this would be your final answer for this one, okay? Okay, so the last one that we're doing, this is the last one for this video, and that'll be it. Because I know I'm kind of going overboard. So the last one is going to be 2 log base 3 of x, and then minus 3 log base 3 of y minus 4, and then minus 4 log base 3 of minus 1. And we want to condense it. So again, remember that if you have any number in the, so here's the thing, if you have any number in the front, you're going to move it to the exponent up here. So that means that 2, this 2 right here, is going to be moved over here because you're condensing it. So it's going to be log base 3 of x squared. So this is this, right? And then I'm going to say minus 3, and I'm going to say, and it goes the same thing for 3. I'm going to move it up here. So I'm going to say minus the log, I'm going to say minus log base 3 of y minus 4, and I'm going to say that this, and let's go ahead and put some brackets, so like this, but I'm going to say of the quantity y minus 4, and I'm going to say, I'm going to go ahead and say cubed. So let's see, give me 1 second. So we are going to do this, so we're going to put 3, we're going to put it right here, and then we're going to close the bracket, and then minus, and it's going to be, and then the 4 here, that is right here. So let's kind of color code that so that you guys know exactly what I'm doing. This is 4, so I'm going to move it over here. So I'm going to say minus log base 3 of the quantity, and I'm going to put brackets so that you guys know that the entire logarithm is not being to the raised to the 4th power, but it's going to be z minus 1, and then it's going to be raised to the 4th power, right? So then it's like this, right? And now, since it's all being divided, what you're going to do, and this one I am going to say, this one is a little bit tricky, because the thing is that, so here's the thing, what you're going to do is you're going to make it so that, so you have log base 3 of x squared, right? And then here's the thing, since you have a minus and a minus, we can factor out a negative out of here. So we can say minus the quantity, log base 3 of the quantity y minus 4 cubed, like this, and then plus log base 3 of the quantity z minus 1 raised to the 4th power. Okay? The reason why I did it like that is because I want to make sure that I am not confusing myself when I am dividing these two logarithms, because they are a difference of logarithms. The thing is that I mean, you can divide it, but you're going to have to use the dividing fractions rule, okay? And the thing is that that's here, so, but if you're not good at using the fraction rule, that's kind of why I factored out a negative, so that way you can just use the products rule here, or the product property, and then you can just go ahead and use the quotient property here. So I'm going to say this, log base 3 of x squared, and then minus, and I'm going to say, it's going to be the following, log base 3, and I'm going to make an entire quantity, because again, anytime I'm adding two logarithms, I am going to add whatever is on the inside. What is the inside? The inside here is y minus 4 cubed, and then the inside over here is z minus 1 raised to the 4th power. So I'm going to say the following, minus log base 3 of the quantity y minus 4 cubed times z minus 1 raised to the 4th power. And so the thing is that, so here's the thing, now it's a little bit better because now we can actually go ahead and use the quotient property. So that means, so basically here, if I make u equal to x squared, and I make v equal to the following, y minus 4 cubed times z minus 1 raised to the 4th, I can say that this is really log base 3 of u minus log base 3 of v. So what is that going to mean? That's going to mean this, log base 3 of u over v. So that means, because u equals x squared, because I said u equals x squared here, and I said that this entire term is v is y minus 4 cubed times z minus 1 raised to the 4th. I made this rule here, okay? So here's the thing, how we're going to do this, and we're going to go ahead and finish it off. We're going to say log, this is going to be log base 3 of x squared over, and I'm going to just go ahead and put whatever I put for v. So it's going to be over y minus 4 raised to the 3rd power times z minus 1 raised to the 4th power. And this is your final answer for this one, okay? Okay guys, so that is it for this video. It was a little longer than expected, I know. And I do apologize if I took a little bit long, but I really wanted us to understand exactly how these are. And the thing is that I want to be, like I said, when I do my videos, I want to be very clear as possible. And so if anybody has any questions about condensing or expanding logarithms, this video algebra or algebra, if you're in college algebra, algebra 2, if you're in algebra 2, but more specific college algebra. And so the thing is that I really recommend that you guys have the properties in front of you if you're practicing these, because that'll really help you with understanding what's done, okay? So with that being said, guys, thank you so much for watching, and if anybody has any questions, please let me know. Please like, comment, and or subscribe, and I will see you guys in the next video. Bye guys.